The images you are about to see are not pictures, but parables intended to ambush reality. The images invite you to construct the Gothic Cathedral of Notre Dame of Amiens. Its imaging of heaven, its location in time and in the earthly city, its design in the measure of man and heaven, its construction, its structural behavior and fragility, and the power of its forms and spaces, revealed through the metaphor of Daedalus's flight. In the clouds we catch a glimpse of heaven. The celestial city is superimposed upon the earthly city, Roman Amiens. We see the grid system of the Roman city, the late Roman city wall, and the anticipation of the Gothic cathedral. The late Roman city turned into the medieval city with its industrial northern suburb enclosed inside 12th century walls. We find ourselves dropping on the city, dense packed houses crammed inside the recently constructed wall, population between 15 and 20,000 people living in 2- and 3-story wooden houses, dominated by the massive chalk bulk of the Gothic cathedral. As we skim over the rooftops, the cathedral turns to reveal itself. First the west facade, and then the southern flank. It is through the myth of Daedalus that we are able to fly like gods or goddesses. We can comprehend the entirety of the cathedral, the cruciform shape of the transept, the flying buttresses, the central spire. With Daedalus we fly, with Icarus we fall. Through the nave roof and vaults, and at our feet we see on the nave floor the labyrinth, known in the Middle Ages as the House of Daedalus. At the center of the labyrinth, the octagonal plaque celebrates the creativity of the 3 architects and the founding bishop. From this plaque, we take the first master mason, Robert of Lussage. And as we listen to the music of Perrotin, composed as the cathedral was being built, Robert will demonstrate for us his method of design. The cathedral is built in the measure of man and of heaven. It is laid out using the Roman foot of 29.5 centimeters. As Robert walks, he leaves behind him a trail of foot units. The feet are gathered into 10-foot squares, which are themselves gathered into a great central square of 50 feet. Noah's Ark was 50 cubits, the cathedral 50 feet. They are both vehicles of salvation. The square turns into a space matrix, and the 4 crossing piers are located. The span of the aisle is created by means of a golden section. The square is halved, the diagonal of the half square is rotated, giving us a 5-to-3 relationship, 50 to 30 feet. The image turns gold to indicate the golden section. The central 50-foot square is surrounded by a peripheral space of 30 feet, creating a double square. This is the image of heaven that we saw at the beginning. Heaven is encoded in the central space of the cathedral. The spaces of the cathedral are unfolded outward from the great central square using dynamic geometry. First come the transept arms, rotating outwards like windscreen wipers. Next, the diagonal of the great square swings to give the length of the nave, creating a square root of 2 rectangle. The half diagonal gives the length of the choir, creating the great cruciform shape. The same strategy gives the choir aisles. The center point of the hemicycle is located slightly to the east of the last division. We find this point using the diagonal of the choir, and from this center is struck the hemicycle and radiating chapels. The bay divisions are inserted, and the height of the edifice is found through the rotation upwards of the great central square. The cathedral is built ad quadratum. The resultant space matrix has a kind of Platonic clarity and beauty. This was the vision of the cathedral entertained by Robert of Lussage and the clergy at the start of work in 1220. However, 50 years of construction, of push and shove, separated the vision from its final realization. We will now watch the cathedral going up. Work began along the southern flank of the nave with the west facade. The north nave aisle follows a little later. Robert of Lussage was probably asked by the clergy to create a provisional liturgical space that would serve for the immediate celebration of the offices. In this way, the south nave aisle and the south transept aisle were finished in the first 5 years of work. With the north nave aisle completed soon afterwards, probably around 1230, Robert of Lussage died and was succeeded by his former collaborator, Thomas of Caumont. In the 1230s and 1240s, Master Thomas constructed the upper nave, simultaneously laying out the lower choir. Bells were hanging in the southwest tower by 1243. Thomas of Caumont died in the later 1240s with the upper nave complete. He was succeeded by his son, Renaud of Caumont, who in the 1250s and 1260s constructed the upper transept and choir. Renaud changed his father's forms, introducing a different type of triforium and a different flying buttress. The choir flyers are placed too high and are too light to be effective. Renaud thus becomes a type of Icarus, a disobedient son, destabilizing the authority of his father's structural system. The upper choir was finished towards 1269. The flying buttresses built by Renaud of Caumont are ineffective. They are placed too high in relation to the main vaults. In the late Middle Ages, the main supports buckled. The flyers were dislocated. The cathedral was saved through the insertion of an additional flyer placed underneath the original support. We enter the model in order to explore its spatial complexity. The model becomes a linear matrix, echoing the linear intensity of Gothic. We move down the south nave aisle into the crossing space, sensing the diagonal expansiveness of the crossing area. We enter the double aisle of the choir and circumnavigate the ambulatory, leaving the radiating chapels to our right. We return along the choir north aisle, back through the crossing space, into the nave. Entering the nave main vessel and looking upward, we sense that the building is made of squares. The aisle vaults are perfectly square, the nave vaults are double squares. We approach the great central square into the crossing space. The crossing piers are slender and are pushed inwards by arcade walls meeting at 90 degrees. The piers buckle and would have collapsed. The collapse was averted in the late Middle Ages through the addition of a massive iron chain that pegs the piers in place. With an anagogical upward lifting conclusion, we end where we began, in the heavens.
20 years ago, we started talking about developing a video program on the basis of art humanities. The idea was that there was an audience out there waiting for it. I mean, just as we would put together a course, we would be able to send our best instructors, as it were, over the networks, through the wires and so forth. That has now developed, I think, much more actively, much more dynamically into what we're doing now. It becomes increasingly possible to make much more articulate the experience of architecture, both in terms of the viewer as spectator, as moving spectator through space, but also in terms of the analysis of construction.
Intellectually, it will be a means, I hope, that a department that prides itself on being one of the best, or perhaps the very best, art history departments in the United States can begin to project itself into a much wider community. It's one thing to deal with a picture, which is a two-dimensional surface, using images projected on a wall. A building does not respond so readily to that kind of image. Intellectually, the subject of my current book and my current research really has to do with the process of becoming and the process of change, the phenomenon by which one thing becomes another. Yes, the kind of partnerships that one finds within the framework of a project like this are rewarding, amusing, entertaining, wonderful. The creative forum that we had established to make the Amiens project, that includes Eden Muir and Rory O'Neill and our other colleagues across campus, has been one of the most rewarding frameworks, really, that I've encountered since coming to Columbia.
Of the different types of projects that are going on at Columbia right now, the Amiens Cathedral project was one that has really planted a flag on top of a mountain and has demonstrated that not only is the cooperation between departments potentially a wonderful thing, but more generally that these technologies are not just things that should remain in the sphere of the film industry or specialty industries, but can come to bear on a wide variety of fields and show a big promise for the future of education, where telecommunications and electronic distribution of these materials becomes important and essential, actually, and that if you take something like art history, which you don't normally associate with special effects and high tech, and mix it with this, there's the possibility that it will bring this type of information to a very large audience in a fun and easy to understand way, and that this could be happening in all departments.
Well, the process was fascinating because we had to generate 22,000 frames of full-screen video, which is something that no school of architecture has ever done before and probably will never do again. It was a remarkable experience. First of all, we had to do the brunt of the rendering, which is the really difficult task. After final exams were passed and final reviews were over, it meant basically taking over every machine in the building, putting it toward this task, as well as engaging in collaborative arrangements with the School of Engineering to get their large machines rendering for us overnight. So for a period of several weeks, we had every Silicon Graphics station on campus working for us, including the 2 giant supercomputers at engineering. So literally what was happening was every day we were going downtown on the subway several times with a very large hard drive containing 4 gigabytes of high-resolution images, and these were being dumped to tape.
Well, the Amiens project has been a test bed for us in order to experiment with new imaging techniques, with producing video on a great cathedral, to animate that cathedral with soft image, an advanced animation package, to create moving images, because we've never had moving images in the classroom before at Columbia in teaching art history. And we found that that is particularly effective in bringing three-dimensional objects like a great cathedral across to students, many of whom probably have never seen a cathedral like Amiens before.